Okay, so let's go and try another example of an IV push. And let's go and do example 11.11. Okay, so we have an order for this drug. Okay, 1500 milligrams IV push immediately over 4 minutes. And that says the 2-gram vial has a strength of 1 gram per 10 milliliters. Okay, so the first part of the question asks you to find the total number of milliliters you will administer. Okay, and notice that the strength is given as grams per milliliter. Okay, but the amount in the order is in milligrams. Okay, so we can quickly convert the amount given in the drug order, okay, into grams. Okay, so we're going to go from milligrams to grams. Okay, so we know that there in 1 gram we have 1,000 milligrams. Okay, so we're basically going to take 1500 and divide by 1,000 to go from milligrams into grams. So 1500 divided by 1,000. Okay, that's equal to 1.5 grams. Alright, so now we're going to take the 1.5 grams. Okay, and multiply by the reverse of the strength. So what I mean by that, you're going to flip it over so that the milliliters are on top, and then the grams are on the bottom. So the way that the strength is expressed, right, the 1 gram is on top, and then the 10 milliliters on the bottom. So we're going to flip that around. Okay, so you have 10 milliliters on top. Okay, and then 1 gram on the bottom. Okay, so we're going to multiply by 10 over 1. Okay, that's going to eliminate grams, so we're going to go from grams into milliliters. Okay, you can do a quick mental calculation and double check it with your calculator. So 1.5 times 10 is equal to 15. So we're going to administer 15 milliliters. So 15 milliliters will be administered, okay, to the patients. Okay, so part B says, determine the number of milliliters you will push during each 30-second interval. Okay, and in the problem it says to do the IV push over a period of 4 minutes. Okay, so we can do what we did with the previous example, right, where we converted the 4 minutes into seconds. Okay, so 4 minutes, right, is how many seconds? Okay, you can probably figure this out in your head, but let's go through it using dimensional analysis. Okay, so we know that there are 60 seconds in 1 minute. Okay, so we're going to take 4 multiplied by 60. Okay, so 4 times 60 is equal to, 4 times 60 is equal to, okay, 240. So that's 240 seconds. All right, so to figure out how many 30-second intervals there are in 240 seconds, all right, we're going to divide that by 30. So 240, okay, divided by 30 is equal to 8. Okay, so 240 . Okay, divide by 30 is equal to 8, so therefore, okay, there are 8 30-second, so 8 30-second segments, okay, in 4 minutes. Okay, so what that means is that we're going to take okay, the flow rate, okay, which is 15 milliliters in 4 minutes. Okay, so in other words, the flow rate of the IV push, right, is 15 milliliters over 4 minutes. Okay, so 15 over 4. Okay, so let me just input the units here. So remember, there are 240 seconds in 4 minutes. So this is like saying, okay, the flow rate is 15 milliliters over 240 seconds. Okay, so let's just quickly change that to 240 seconds. Okay, so what we're going to do is going to divide the numerator and denominator by 8. Okay. Okay, what that's going to do for us is it's going to tell us how many milliliters to push every 30 seconds. Okay, so we know that 240 divided by 8 is 30, so we're going to end up with 30 seconds in that denominator. Okay. Okay, but what we need to figure out is 15 divided by 8, so let's put that on our calculator. So 15 divided by 8 okay, is about 1.875. Okay, you might round that. Okay, so 1.875 milliliters. Okay, so it may or may not be possible to administer 1.875 milliliters every 30 seconds. So you round that accordingly. Okay, so since it's bigger than 1 milliliter, okay, you can round that to the nearest tenth. So to the nearest tenth, that's approximately 1.9 okay, milliliters every 30 seconds. Okay, so in other words, because the problem asked you, right, how many milliliters you will give in each 30-second interval, okay, well, we just figured out that there are 8 30-second intervals. Let me change that to intervals. So 8 30-second intervals, okay, in 4 minutes. And we figured that out by converting the 4 minutes into seconds and then dividing the number of seconds by 30. So there are 8 30-second intervals in 4 minutes. Okay, so we take the flow rate in milliliters per minute and divide the top and bottom of that fraction by 8 and then round accordingly. Okay, so to administer the medication via an IV push, right, we would push 1.9 milliliters into the patient's body every 30 seconds, right, until we complete the infusion. Okay, so the last part of the question is asking us to determine the number of seconds needed to deliver each milliliter of medication. Okay, so this isn't as tricky as it sounds. Okay, so we know we're supposed to administer 15 milliliters over 4 minutes. Okay, and we know that 4 minutes is equal to 240 seconds. Okay, so we're going to take the total number of seconds, okay, which is 240. All right, and then divide by the number of milliliters. Okay, and if we put that on our calculator, so 240 seconds divided by 15, okay, we get 16. Okay, so in other words, it's going to be 16 seconds. So 16 seconds per milliliter. All right, and that's how you answer that question. Okay, so in other words, this is a little bit cleaner than this one, and I say cleaner because, for one, right, in the previous question we you know, we got kind of a weird decimal number, like 1.875. Because like I said earlier, right, it may not be possible to administer that exact amount every 30 seconds, which is why we had to round it. Okay, but here, right, it tells us, okay, every 16 seconds we're giving precisely 1 milliliter of the medication. Okay, so you can think of this another way, right? So every 16 seconds you can push 1 milliliter of the medicine into the patient's body until you complete the IVP infusion. Okay, so the next topic we're going to do is on titrated medications. So the process of adjusting the dosage of a medication based on patient response is called titration. Orders for titrated medications are often prescribed for critical care patients, so such orders require that therapeutic effects, such as pain reduction, be monitored. The dose of the medication must be adjusted accordingly until the desired effect is achieved. Okay, so we're going to discuss how to construct what are called titration tables. Okay, so with problems that involve titrated medications, okay, there is an initial dose. Okay, and usually these types of medications are given through an IV. Okay, so there's an initial dose, a dose rate at which the medication, or at which the patient is receiving the medication. And if there's no response, if the desired response is not present, then you increase the dosage. So to increase the dosage, you increase the flow rate at which the patient is receiving the medication through the IV. And that's kind of the idea. So in the next video, we'll look at a couple of examples of titrated medications.